this is maybe a tangential question, but why it feels like antibiotics should have
Why
been...
didn't humans evolve their own antibiotics? Yeah, it's actually an excellent question that I haven't heard posed before. So we think about, where do antibiotics come from? To your point, we could synthesize them. They're just metabolites largely of other bacteria or other fungi. You think about the story of penicillin, what happens? Alexander Fleming finds some fungi growing on a dish, and the fungi secrete this penicillin antibiotic compound, and so there's no bacteria growing near the fungi. And he says he has this light bulb moment of, oh my gosh, they're probably making something that kills bacteria. There's no prima facie reason that you couldn't imagine encoding an antibiotic cassette into a mammalian genome. I think part of the challenge that you run into is that you're always in evolutionary competition. So when you look at competition between bacteria and fungi that are all trying to compete for the same niche, what you find is they're evolving very rapidly in competition with one another. It's an arms race. Every time a bacteria evolves a new evasion mechanism, the fungus that occupies the niche will evolve some new antibiotic. And so part of why that there is this competitiveness between the two is they both have very large population sizes in terms of number of genomes per unit resource they're consuming. There are trillions of bacteria in a drop of water that you might pick up. So there's trillions of copies of the genome, massive analog parallel computation. And then at the same time, they can tolerate really high mutation rates because they're prokaryotic. They don't have multiple cells. So if one cell manages to mutate too much and it isn't viable or it grows too fast, it doesn't really compromise the population and the whole genome. Whereas for metazoans like you and I, if even one of our cells has too many mutations, it might turn into a cancer and eventually kill off the organism. So basically what I'm getting at, and this is a long-winded way of getting there, is that bacteria and other types of microorganisms are very well adapted to building these complex metabolic cascades that are necessary to make something like antibiotics. And they are necessary. It's necessary to maintain that same mutation rate and population size in order to maintain the competition. Even if our human genome stumbled into making an antibiotic, most pathogens probably would have mutated around it pretty quickly.
Wait, actually, that should imply that there's millions of quote-unquote naive antibiotics, all these molecules which could have acted as antibiotics, but they're the penicillin that was invented 1 billion years ago. Do we see evidence of these like historical antibiotics that some fungi came up with and bacteria revolved around, and there's evidence for remnant in their DNA?
My strong hypothesis would be yes. I can't point to direct evidence today. There are some examples of this where, for instance, bacteria that fight off viruses that infect them, bacteriophages, have things like CRISPR systems. And you can actually go and look at the spacers, the individual guide sequences that tell the CRISPR system, which genome do you go, where do you cut? And you find some of these guides that are very ancient. It seems like this bacterial genome might not have encountered that particular pathogen for quite a while. And so you can actually get sort of an evolutionary history of what was the warfare like, what were the various conflicts throughout this genomic history, just by looking at those sequences.
If you enjoyed this clip, you can watch the full episode here and subscribe for more clips. Thanks.